Hello, everyone. Welcome to the eighth episode of Smart City Waters webinar. Today, we're going to talk about the second part of dual drainage modeling. If you guys just happen to just came here and not checking out the last episode, feel free to go to our YouTube channel. The YouTube channel's name is Smart City Water Incorporation, or INC dot. And then you can check out all of the episodes that we had so far. We talked about climate change impact. We talked about how to do a land development. We also talked about VO swim and the first part of the dual drainage modeling, which was basically more of the theoretical of what is dual drainage modeling, is also there. So make sure you go there, you subscribe, check out, because we do also we are working on some video tutorial that we're going to post it on our YouTube channel. So make sure you keep posted over there. So with no further ado, I will continue doing the dual drainage modeling. So as we talked about dual drainage modeling in the first part, we said that so what exactly dual drainage modeling is that we technically want to connect the overland runoff that we generate, and we want to connect it to the sewer system that we have. We have two types of sewer: storm sewer and sanitary sewer. So, and this overland runoff will flow into both of these sewers. Um, so from the catch basins, it normally goes to the storm sewer, and also the manhole of the sanitary sewers uh, is a vulnerable place for the storm sewer to flow in there. So today we're not going to talk about the manhole I&I analysis. The manhole I&I analysis is exactly on August 31st. And then that is going to be um, the ninth session of Smart City Waters webinar. And then we will talk about the new ECACLI legislation that just kicked in Ontario as well, that requires the manhole I&I analysis for um, putting the new manhole sewers. But for this session, we'll focus solely on the dual drainage modeling. And just in case if anyone shows up today and didn't get a chance to come or check out the video of the last session, I will start the VO swim from scratch. And then for this example, I will bring up the DM and everything. And it is also available if you guys want, just email me after the session. I can send you either a link or the document or any data that you need to do this practice. So I will share my screen. So after opening the VO or VO Swim, which by the way, both of them work under the same installer. So I open a new swim project, and then this is what I see under the map view of my software. So make sure at the very beginning, make sure that under the properties tab, make sure that the unit is on CMS and the link offset on elevation. So that was the very first thing that I need to do. And then I just want to make sure that I am uh, technically saving. Like I want to save this project because I don't want that anything happens to my project. So I will go to webinar number 8. I will save it as session 8. So the project is saved. So the first thing that I want to do is I want to import any shapefile that I have. At first, I want to build up my sewer system, any shapefile that I have, manholes, conduits, catchments or subcatchments. I want to build up them or build them up and then add the storm data to the model, run the model, and then work on the overland flow. So in order to do that, what I need to do is I need to go through the micro drainage ribbon, import layer. And the first layer that I want to import is my junctions, is the manhole. So I will click on junction, import source. I have the data, the shape file for my junctions, which is the manholes. And then I will load the junction nodes, and I will make sure that the attribute of the shape file is assigned to the correct attribute of VOSwim. For instance, Nash height, the attribute of my shape file for the junctions of mine or for the manholes are called node ID. I will make sure that all of them are assigned correctly and then click on import. You will see this notification. Click on overwrite. Make sure the sanitary is assigned to sanitary and the storm to storm. So the first one is added correctly. So what I want to do next is I want to add my conduits. So I will click on conduit, import source. I will go and find the sewer shapefile of mine. Do I want to clear the current mapping? Yes. I will load it, conduit, and then I will make sure again that the attribute of the shapefile are assigned to the correct attribute of VOSwim. Import, overwrite, make sure that it is on sanitary and this is on storm. We have other type of conduits as well, but for this example, we are working with the sanitary sewer and the storm sewer. And the last thing that I want to add is my catch basins. So I will go on the catch basin, import catch basin shapefile. I will open it and then load. Again, make sure they're assigned correctly. And then I import it and I overwrite that. And then when it's done, I close it. So if I can't see anything here, there are two ways to actually find out where we are or where we actually import them. You can go and find it on the map, which I believe it is here in Newmarket area. But another way to do it is just going on the junction or something that I imported to the software and then zoom to the layer. And it just zoomed into the layer. So this is what I so far added to the software. And then the next step to do so is to add my storm data to the resource library. And then after that, add it to the model. So if I go to the resource library under the simulation tab, I can make a new, let's say, subfolder if you want to save it on your library. If you want to build up a new library for yourself, I will add a new folder. I will call it webinar number 8. So webinar number 8, and I want to import my my data, my storm data. In the new design storm, read in, I will click on it, and then I will find out where exactly it is. So it is under the data folder, but make sure that you're looking for the CSV. If you happen to have the storm file as well, that's awesome. You can import the storm file, but if you have this the CSV file, you can import the CSV file, and mine is rain data. I will click OK. Unit is a metric, that's correct. And then I need to add this to the model. If I click on add to model, this is the rain group, yes. And so this is added to the model. Now it's up to you if you want to save this data on your resource library that you can use it for further or in the future futures projects or stuff like that. You can save it. If not, you can just let it go. But I want to save it, so I will save it here and then I will close it. And then on the project manager, you can see that the new data is also added here as well. And also we have a new run, it's called scenario 1, and it's the rain data. So now we can run the model, but always make sure before running the model, make sure to check the error list. I have 2 errors. These errors is gonna cause some issue when you're running. So before running the model, always check the error list. And if you double click on them, it's going to take you directly to the location that the error is happening. I will double click on it. So this is, it's flashing. This is where the error is happening. And the error is the node does not have a link out. So as you guys can see, this is the end of my sanitary system. The flow of the sanitary system is coming this way. This is the end of it, and it needs an outfall. What I need to do is I will just bring an outfall. It's a dummy outfall, but I need to do it because any system needs to have an outfall at the end. I will click on it. I created an outfall, and I need to connect the last node of my sanitary system to this outfall using a conduit. I will drag and drop, go to the last part, and then this part, and then I connected them together. What I need to do is I need to make sure that the system type of this conduit is sanitary as well. I will select it, go to the properties tab. The system type is blank, but I need to make it a sanitary. The shape of it, make sure it's a dummy one because it's not an actual conduit. And then this is the last node of my sanitary system. The invert elevation of that should be the same as the inlet elevation of this dummy conduit as well as the outlet elevation of this conduit. So this conduit now is a sanitary conduit. And also I need to make sure that this outfall is also a sanitary outfall. And also the ground elevation should be the same as the invert elevation of this node. So technically I'm just adding a dummy outfall here. And then the invert elevation should be that one as well. So that was the first part. And then as you can see, the error is gone. The second error is the same thing, but for the storm sewer. What I need to do is I need to do the same thing, add an outfall and a conduit that connects the last node of my storm system to the outfall. And then again, I need to make sure that the invert elevation of the last node of my storm system should be the same as this conduit's inlet elevation and outlet elevation. And also, the system type is a storm here, not sanitary anymore, because we're working on a dummy outfall for the storm system. And then the shape should be dummy shape. So this is the conduit, and I need to make sure that I'm doing the same thing for this outfall as well. The system should be storm. The ground elevation and the invert elevation should be the same as the last node of my storm. So I don't have any error anymore. All I need to do is I already added my rainfall data to the model. All I need to do is I need to go and run my model. But before that, I want to make sure under the simulation ribbon on the engine, I want to make sure that I'm getting the report every 5 minutes. So that was 15. I'm going to change it to every 5 minutes. Everything else, the routing is 30 seconds. It's fantastic. And then I'm going to click on run. The setting, you can change the name of this run. You can change the name of the rain group. But I want to make sure that I am getting 12 hours for the end of the analysis. And then change the setting here. I will click OK, and now I can run the model. So the model is run, but this is only for the drainage system. This is only for the sewer system. What I actually want to do is now I want to add my DEM file to the model. And then after adding my DEM file to the model, because DEM has the physical characteristic of my watershed, of my region, of my area. So I need to add that. I need to add my DEM. And then after adding the DEM, I also have the shape file of the buildings of that region, of that area. And then using those two, I can generate the flow path and the sag area. I can find out where is my sag area. So in order to add the shapefile. I will just zoom out to make sure we're seeing the same thing. All right. So I will go to the GIS tools. Excuse me. The GIS tools, add layer. I have my DEM here. I will add it. This is my DEM. And I also have, if you want to change the color of it, you also can do it, but I'm okay with it. So I also happen to have the shapefile for the buildings in that region. I also will add the shapefile for the building, but it's not shown here. And the reason is because the building layer is lower than the DM layer. I will bring the layer of the building up, and there we go. Now this is the shapefile of the building in that region. Using these two, we came up in VO Swim, we came up this micro drainage ribbon that you see here is all for dual drainage modeling, and it makes the modeling of overland flow and connecting it to the sanitary or the storm sewer very easily, and it's going to save a lot of time. So I want to run the DM and get the sag area as well as the flow path. But the flow path, the good thing is, if we happen to have the building shapefile, the flow path wouldn't go through the buildings. So I will click on Run DM under the micro drainage ribbon. The DM layer, so this is my DM that I have. The internal wall layer is the building. And here, sometimes it is 1, sometimes it is, I don't know, 0.1, but the less the number, the high resolution you will get, the flow path. So I want to go with 0.01, and also I need to assign a location, a path that I want the result, but because it's going to generate a lot of results, so I want to make sure that I am going to um, I'm going to save it somewhere. So I have to assign a path to that one. So I'm going to find the webinars, the 8th session, and then I will click OK. So it's going to start generating like fill them, wall them, and so many other results. And while it's running, you guys feel free to let me know after the session if you guys are interested in checking out VOSwim if you're not currently our client in VOSwim, and I can easily just generate a free trial for you guys, and so you guys can have a chance to check it out and see if you guys are interested in it. So the flow slope, I don't need any of these results that it's generated for me. They're very useful, but not for this practice that I'm doing right now. What I need is just the flow path and the sag area. So wall dam, I don't need it. I will uncheck it because I don't want to see it. And also the DM. There we go. Now we can see the flow path that is not going through the buildings. So I also want to see the flow path, the direction of my flow path as well. And you can see that since sag area, the layer is higher or is on top of the flow path, I won't be able to see the flow path here. So I will just bring the flow path layer one layer up. There we go. Now I can see it. So this is a sag area of mine. And you also can turn off the base map if that makes everything complicated. So I want to see the flow direction of my flow path as well. So what I need to do, the flow path, I will click on it, right click on it, show/hide arrow. If you click on that one, then it's going to show you where exactly the flow path is flowing, the direction of the flow. So this is what I currently made so far. So the next step for our dual drainage modeling practice is to add the overland nodes and conduits. So now I have everything underground ready. I need to build up the overland flow and then go from there. So what I need to do is I need to add the Overland node on the flow path and then go from there. But before then, I will just talk a little bit about the recommendations about where and how to add the Overland nodes. So it is recommended to place the Overland nodes on flow path first of all, because we are technically modeling the reality, and the reality is on that flow path. The flow is the runoff is flowing. So first of all, the recommendation: place your overland node on the flow path. Make the overland conduits match with the flow path direction. We do have the direction, and as you guys can see, we have the directions here. If you're having if you're placing your conduits, make sure the conduits are in line with the direction of the flow path. And then there are always debates, and it's a very engineering idea, or it's up to you guys when and how many nodes you want to assign. But technically what they're saying is we need to place an overland node at a start point of a flow path, like here. And as you guys can see, this is the start point of the flow path, or on the catch basin, if there is any catch basin, or if there is any inlet along the flow path, just place one overland node over there. When there is a sag node, a sag area, so you can create a sag node or a storage unit there, or at a junction, when two flow paths are meeting together, or if there is any sanitary manhole, or if there is any catch basin, as I mentioned before. So if there is any change on the characteristic of the region, place an overland node there. It wouldn't hurt, but um, over placing the overland node, I just made a word up. So if you put the overland nodes too much, that's also going to affect negatively our modeling as well. But for this part, I'm going to place it at the beginning of the flow path, obviously, because we have a sanitary manhole here. We have a catch basin here, so I'm going to place one here. We have another sanitary manhole here, so I'm going to place one here. So, and as you can see, we have three branches technically. One branch is here, one branch is here, and one branch is here. So we talked about this branch. For here, I have one sanitary manhole here. So for sure one here. And also the same thing is going to be connected to these catch basins, because we have to connect our overland nodes to the sewer system. Both catchment basins, which overland flow will enter the storm sewer, as well as the sanitary manholes. And I'm going to place one here because we have two catch basins here. And same thing is going to be connected with this sanitary manhole. And probably one here too, because we have one sanitary manhole here. And in the other place, we have one sanitary manhole, two sanitary manhole, and potentially I will just put one here as well. So in order to place them, what I can do is I can just add these junctions and go from there. But because I'm working only on overland nodes now, I can change the default of these junctions. So in order to do that, I need to go under the simulation ribbon, default values, nodes/links. So the node/links, this is the default of the nodes. If I change these defaults, if I add any node, then the nodes are going to have these values in the very beginning. I can change them down the road, but I want to save some time. So the node max is 0.3, the conduit's roughness, the street, so it's 0.013. The pipe shape, it's again, we're talking about the overland flow, so it's an irregular, it's not circular, irregular, and the system type is overland. So this is I changed the default values for this node. So now if I add any node, the node is going to have these default values. So I will bring this down. I will drag and drop. This is the first node that I will create. The first one is created, and as you can see, it's an overland one. And then 0.3 is the full depth, as well as the roughness is 0.013. So if I want to place the second one, and if I want to avoid adding the conduit at the end, I can just hold the control button on my keyboard and then add the second one. And the conduit is going to be generated automatically. This is the second one, and then the third one, all of them on the flow path and then the direction of the flow path. So this is the first side of my area. I will go to this branch. So for this branch, I will place one here, and then I will place one here. And then I'm going to place one here as well. I'm going to place one in here. But as you know, since I came out of adding the nodes, I need to add a conduit from this node to that node because it's not connected. So the conduit from this node to this node is also connected. Just gonna make sure that it is from 55 to 57. And that was 57. Perfect. All right. So this is also the second branch of my area. The third one is here. I will add the junctions. This is the first one. This is the second one. And I'm going to put one here as well. The third one. So I created the overland nodes of these three branch, and I need to create one also here, but here is a sag area, and in the sag area I need to add a storage unit. And we also came up with a tool to create the sag node, and also when you create the sag node, VOSwim automatically is going to generate the storage curve so that you don't have to worry about it anymore, or you don't have to have the data necessarily. How does VOSwim generate that storage curve? It's generated it based on that DM that you created the storage or the sag area. So what I need to do is I need to go under the micro drainage ribbon, create sag node, and then I'm just going to put it on the side. So all I need to do is I need to click on start. I'm going to zoom in here. I need to click on any of this region on this sag area. You see this red dot. And then when this red dot showed up, I need to go on the flow path and then just click on the flow path. It automatically generated this this storage unit for me with the storage curve, and it's over. So I have this storage node right now. So what I need to do now, I need to connect these nodes that were away from the storage pond, the sag area. I need to connect them to the storage unit. So using conduit, I will drag and drop, go on the last node of this branch, click on it, and then click on storage unit. The first one is created. I will go to this branch, using conduit from this area, from this node, which is an overland node number 52, to the storage unit. And then the last one, I'm just gonna turn off the flow path because I want to see exactly where I'm placing them. The conduit from this area, from this node to the storage node. And then I'm going to turn back on. All right, so I connected them all together. My overland system also needs to have an outlet as well, or outfall as well. So what I need to do is I need to connect them because it's flowing out from here. I'm going to put a node here and also an outfall here. And then I'm going to connect from this storage node to this junction. So this is one part of it. And then from this node, I need to connect it to this outfall as well. So another conduit from this node to the outfall. So this is also my outfall. So my Overland system also now has an outfall as well. So what I need to do right now is I need to make sure that the all of my Overland nodes, like this one, for instance, the the checkbox for the delineation should be on. So I can just select them one by one, but in order to avoid that, and that's going to take a lot of time, so I'm going to the parameter table, junction part. Now I'm going to sort all of my junction. If I click on system type, I'm going to sort them all. This is sort based on Overland. So I'm going to click on the first one and then hold the shift button, come down to the last Overland node. So as you can see, all the Overland nodes are checked right now. So I selected all of them, and then I'm going to I'm going to check this delineate option on. And the storage unit of mine, I'm going to click on it. For a storage unit, it needs to be on, and also the sag needs to be on as well. So the next thing that I have to do is I need to go for my Overland conduits, which was irregular, and I need to assign a transit to that one. So I will go to the conduits, do the same thing, sort them based on the system type, select all the Overland conduits. As you can see, all of them are connected or selected here, and the geometry of them needs to be irregular. So I will just go on the properties tab, geometry shape here, and then this will show up. You can select the transit from here, or you can just go over here and select the transit from this tab on this side. So what I want to have is the min local ST with 18.5 meter. I will click OK. You also can check out the grids as well. Like this is how it's going to look like, or you can change the stage elevation if you happen to have the data for a stage elevation for the Overland transit. You can just edit it here. It works like an Excel file. You can just select and edit that one. So that is what I wanted, and I will click OK on it. So all of my Overland flow, or the conduits of them, now have a transit as well. Now I need to assign the catch basins to a node. I need to make sure that the node, my Overland node, is connected to a catch basin, because the catch basin also is going to be connected, and then that node is going to be connected to the storage, the storm sewer. So in order to do that, I will just click on any empty space to unselect everything. I have this catch basin here. This is my catch basin. I have this catch basin, and that needs to be connected to this node, because then I will have my sub watershed or my sub catchment flowing to this catch basin, and then this catch basin to this node, and this node should be connected to the storm sewer. So I'm technically connecting the catch basin to the storm sewer. So what I need to do is I need to connect this to this node. And again, we came up with a tool in VO Swim, assign catch basin under the micro drainage ribbon. If you click on it, all you need to do is you need to draw a box that the node and the catch basin are located in that box. Then it's going to select these two automatically. It will tell you the number of catch basin is 1. The major node is number 50. If I click assign, then you see that these two are connected with each other. So that was one on my catch basin. The other catch basins that I had were here. I have 4 catch basins here. And these 4 catch basins should be connected to this overland or the major node. Again, assign catch basin. I will just draw this box. 4 catch basins are connected to this major node. Assign. I had, I think, 2 here. Yes, 2 of them are here. I need to assign it to this major node. Assign catch basin. 2 of them are selected to this one. Assign. And I have no catch basin here, and I have 4 or 5 catch basins here. 1, 2, 3, 4, and 5 catch basins should be connected to this storage unit or to this major node or the SAG node. Again, assign catch basin. I will draw this. I draw it nicely enough that this node didn't come into this. So if I happen to draw it big enough that 2 nodes show up, you will see this kind of like a warning that 2 nodes, more than 1 overland junction was selected. Which of them do you want to put? And then you can select. Mine is 64, so 5 catch basins are going to be connected to this major node, and I will assign it. Now I assigned my catch basins to my overland nodes. What I need to do right now is I need to say how much of the overland flow is flowing to the sewers, either sanitary sewer or the storm sewer. So first I need to connect these nodes to the sewer system. I need to connect the overland flow to the sewer system. And then I need to say how much water is going to flow in there and how much water is going to be assigned by the capture curve. And we will talk about it after this. So I need to use outlet link to connect. Oh, sorry. I need to, okay, I'm just gonna unselect them all. I need to use the storage, the outlet link to link the sanitary manholes and the storm pipes to the overland system. So I will bring the outlet link. Wherever we have a sanitary manhole, which are these red points, that needs to be connected to my storage, to my overland flow or my overland node. So I will just click on this one. And then I will just select that. And then now my first storage, my first overland flow or overland node is connected to the sanitary manhole. And wherever we have catch basin, like this part, we had a catch basin which was connected to this node. This node must be connected to this node of the storm sewer. So again, wherever we have sanitary manhole, that needs to be connected to an overland node like this one. And whenever we have a catch basin, the node that is connected to the catch basin should be connected to the storm sewer. So I will use the outlet link again and select this one to the storm sewer. It is connected. So the other thing that I had, I can see that I have one here, one sanitary manhole here. So this also needs to be connected. This node needs to be connected to this. And I will come to this branch. There are 4 catchments connected to this node. So this node must be connected to this storm sewer. And also this node must be connected to the sanitary manhole because I have a sanitary manhole here. So I will connect this to here and I will connect this to sanitary manhole. I will continue this. I have 2 catchments connected to this. So again, this node needs to be connected to here, and the same node should be connected to this sanitary manhole. Oh, there we go. So if that happens for you as well, that you accidentally click on something else, just find the node, and then if you click on the node, it's going to automatically connect it to the node. So the other one that I had was here. I have one here, and I believe, yeah, I do have one Overland node here as well. So I'm going to connect this Overland node to this manhole, sanitary manhole. And then I'm going to start working on the other branch, the top branch, and then come back to the sag area. So this needs to be connected. Since we don't have any catch basins, we're not connecting these Overland nodes to these storm sewers. But we have the sanitary manhole, so they need to be connected. Again, one sanitary here. So I'm going to check here. I don't have any sanitary, but I do have 5 catch basins connected to this node. So this node should be connected to this one, to this storm sewer node, and also to this sanitary manhole. But again, I'm going to turn these off for now, just to avoid any mistake. Connect this to this storm sewer node, and it's connected. And connect this again to the sanitary manhole, and I can check them back on. Now I connected all of them to the Overland nodes. So I need to generate my capture curve, because I want to now that it's connected, I want to say how much of the Overland flow is flowing to these sewers. So first of all, what I need to do is I need to go and select all of my outlets. Just easily go to parameter table, go to outlet, and Control A. You will be able to select them all. And then under the rating curve, make sure it's on the tabular depth. And then, as you can see, the curve here, there is no data for the curve here. What I need to do, and make sure all of them are also, the system type is also Overland. What I need to do is I need to assign some capture curve for them. There are some ways that you can generate the capture curve for the manhole lids, but for this example, because we're not working with the manhole INI analysis, we're just solely focusing on the dual drainage modeling. I'm going to import for the sanitary manholes. I'm only going to import the capture curve. So what I need to do, I select them all of them are here. So what I need to do is I need to come to generate capture curve. This generate capture curve is going to tell me what exactly, which type of capture curve do you want to locate? What type of catch basins do you have? Mine is this one. So as soon as I click on generate, it's going to update some of these curves. Update them. Yes. And as you see, some of them are updated. You see that the curve has something in it, and all of these ones are the ones that are actually connected to the storm sewers, because the sanitary manhole has another one. So if you want to import the capture curve, which what exactly does capture curve do is it will tell the software that how much of this overland is flowing to the sewer system. So we'll go to the simulation, the curves, rating, and I will click on import. And the rating curve, if you happen to have it on the rating curve type, then perfect. If not, on CSV also works. And if I click on this, then it's going to bring all the manhole, the sanitary manholes, and then all of them are updated now. You can import the capture curve for your manhole lids or for any nodes that easily. So now all of my outlets also are updated. So what I need to do is I need to add delineation nodes. What delineation node do is delineation node will connect to the major nodes like all of these overland nodes that we created. The delineation node is going to be connected to these major nodes and is going to cut my catch basins in smaller pieces for so many reasons, and one of them can be because you want to bring several branches into one subcatchment, and also you want the result to be more accurate. So it's going to help the software to understand how your catchments is working and how your different branches are flowing to one direction. So what I need to do is I need to click on create delineation. This will pop up. I will click on this node, my major nodes, and then it says selected major node. Nothing will show up here, but you will see that number 49 is selected. And then I will go to the other side of the street. That was the street, if you remember. Yeah, there we go. I'm going to select this, like try to be very straight line to the other side of the street. I will click on the flow path, and now it is selected. I will click on clear, go back to another node. I have one node here, create delineation. I will select this one. Is it selected? Yes, number 50, and then click on here. I will go further. There is one here, so create delineation. This node to this branch. And also I will come down to this branch. I will zoom out a bit. Delineation. So I will select this one, number 54, connected to the beginning of this branch, clear. There is one more here, number 55, connected to the other side of the street. And I will go further because I believe I had one here as well. Yeah. Delineation for this node, number 57, to the flow path. And also I have this branch as well. Create delineation from this node, number 59, let's say to this branch. This node 60 to this branch, and this node number 62 to this branch. All right. Now I add my delineation nodes. Now you can easily generate your catchments. If I click on generate catchment under the micro drainage ribbon, it's going to update my map now. As you see, I have different catchments right now. It generated it based on the delineation nodes, and different branches now are coming to one node. So what all I need to do right now is just run my model, because I connected my overland system to my sewer design. I also told the software how much of the overland flow is flowing to the sewer system. And also all I need to do right now is adding a rainfall data, which I already did, and then run the model to see how much flow is going to be generated, and then how much water is going to flow into my sanitary or my storm system. So all I need to do is I need to run my model. And in order to do that, we're going to go to the simulation, run. That was the same thing because I ran the model, and we'll click on run. So now the model is successfully completed. All I need to do, if you want to check the result, you easily can go and select any point you want, like for instance, this storage unit. I'm interested to see how it is working. So this storage unit, you select it, and then you go to plot result. So this is how it's going to look like. This is the depth. If you want different color, this is the final result. You want to show it in a perfect shape, especially for your reports. If you want to have different parts in it, like total inflow, like if, or flooding, we didn't do any flooding. That's why it didn't show up. But if you want to select the volume or anything, you can just export it and then export this as a picture and export this table as an Excel file and then use it in your report. And if we had different runs or different data, we could run different runs and then we can select which run we want the result from. Or if you want, you also can see it on the result table as well. And then on the result table, you also can sort based on the depth. If you just click on it, it's going to sort it based on the depth or based on the volume and whatnot. Also, if you guys want to see the elevation profile of two different nodes, what you can do is select two nodes. For instance, I already selected that node. I'm going to select this one as well. This is my outlet. No, neither of them. So, and then I click on elevation profile under the simulation tab. It's going to show me how much water it is in there. So if you happen to have some surcharging issue, you actually can find it out here by selecting two different nodes. And by clicking on the elevation profile, you can actually get this, and then you can export it. You can see the results. Some of the detailed value are here. So that was the dual drainage modeling. Um, I remember back in the day that I used to work for consulting a lot. That was a pain to do, especially overland flow. The modeling of overland flow was a pain, but VOSwim, and amazing engineers who are working behind it and develop this amazing software. They're themselves, they've been working in a consulting firm, so they know what uh, how much of a pain it is to actually model, and they're trying to come up with the best case scenario or the best tools possible to save some time from you guys, and then to decrease the amount of headache that we go every day. So that was all I needed to talk about. If you guys have any question, feel free to ask it. We have like around 3-4 minutes left before I jump into another meeting. So feel free to ask any question on the chat. So also, if you guys happen to have any question after the meeting, feel free to email me. If you want this material that I was working and want to practice on your own, let me know. If you guys do not have VOSwim so far, just feel free to text me, because VOSwim right now is the most cost efficient software in the market right now. It is way less expensive than any other software, having a lot more feature, manhole INI analysis, especially for the people in Ontario. It is a new requirement that we need to do that. If you don't have any question, we can just finish this episode right now, and we can see each other in the 9th episode of Smart City Waters webinar, which we're going to talk about the new ECACLI legislation, and then do a hands-on practice on VOSwim and how to do the manhole INI analysis over there. All right. I believe there are no questions. All right. Until the next time, please be safe, be happy and make happy, and have a good one. Cheers.